Good day, everyone. Our topic for today is derivatives. History of derivatives. Calculus, known in its early history as a infinitesimal calculus, is a mathematical discipline focused on limits, continuity, derivatives, integrals, and infinite series. Isaac Newton and Gottfried Wilhelm Leibniz independently developed the theory of infinitesimal calculus in the later 17th century. Derivatives are a functional tools of calculus. The derivative of a function of a single variable at a chosen input value. When it exists, it is the slope of the tangent line to the graph of function at that point. The tangent line is the best linear approximation of the functions near that input value. So, they are basic derivatives rules. Constant rule. Constant rule is d over dx multiplied by c is equals to 0. Constant multiple rule is d over dx times cf of x is equals to c first derivative of cf is equals to first derivative of cf of x. In power rules, d over dx times x raised to the power of n is equals to nx raised to the power of n minus 1. In a sum rule, d over dx times f of x plus g of x is equals to first derivative of x of x plus first derivative of g of x. In difference rule, d over dx multiplied by f of x minus g of x is equals to the first derivative of f of x minus the first derivative of g of x. In product rule, d over dx multiplied by f of x g, times g of x is equals to f of x multiplied by first derivative of g of x plus g of x times first derivative of f of x. In quotient rule, d over dx times f of x over g of x is equals to g of x times the first derivative of f of x minus f of x times the first derivative of g of x over g of x raised to the power of 2. In chain rule, d over dx times f multiplied by g of x is equals to the first derivative of f times g of x multiplied by first derivative of g of x. So the power rule for any number n, d over dx x raised to the power of n is equals n x raised to the power of n minus 1. Example, differentiate and find the derivative of each of the following function. So example is y is equals to x raised to the power of 27. So the derivative of x is equals to x raised to the power to the power of 27 is equals to y is equals 1 over x raised to the power of 27. Another example, y is equals to square root of x is equals to y is equals 1 over square root of x. The constant multiple rule. For any constant c, d over dx cf is equals to c df over dx is equals to the first derivative of c of cf of x. Example, differentiate the function y is equals to 3x raised to the power of 5. So d over dx times 3x raised to the power of 5 is equals to 3 d over dx x raised to the power of 5 is equals to 3 times 5x raised to the power of 4 is equals to 15x raised to the power of 4. So the derivative of y is equals to 3x. 3x raised to the power of 5 is equals to 15x raised to the power of 4. In a quotient rule, example, f of x is equals to 5x minus 1 over 6x squared plus 2. So the first derivative of f of x is equals 6 squared plus 2 times 5x minus 1 minus 6 x squared plus 2 times 5x minus 1 over 6 x squared plus 2 raised to the power of 5. So if the first derivative of f of x is equals to 6 x squared plus 2 times 5 minus 12x multiply by 5x over 1 over 5x minus 1 over 6x squared plus 2 raised to the power of 2. And is equals to 30x squared. Simplify lang natin. So 30x squared plus 10 minus 60x squared plus 12x over copy lang natin ang 6x squared plus 2 raised to the power of 2. So and the final answer is the first derivative of f of x is equals to negative 30x squared plus 12x plus 10 over 6x squared plus 2 raised to the power of 2. In product rule, if the first derivative of f of x is equals to 3x squared minus 1 d over dx times x squared plus 5x plus 2 plus x squared plus 5x plus 2 d over dx 3x squared minus 1. So simplify is equals to 3x squared minus 2 then times 2x plus 5 plus x squared plus 5x plus 2 multiply by 6x squared. Then simplify again equals 6x cubed plus 15x squared minus 2x minus 5 plus 3x squared plus 30x 6x cubed plus 30x squared plus 12x. And the final answer is 12x cubed plus 45x squared plus 10x plus minus 5. in chain rule. So the example is dy over dx is equals to 2x plus 1 raised to the power of 5 d over dx times x cubed minus x plus 1 raised to the power of 4 plus x cubed minus x plus 1 raised to the power of 4 d over dx multiply by 2x plus 5 raised to the power of 5 is equals to simplify. So 2x plus 1 raised to the power of 5 times 4 multiplied by x cubed minus x plus 1 raised to the power of 3 d over dx multiplied by x cubed minus x plus 1 plus x cubed minus x plus 1 raised to the power of 4 times 5 multiplied by 2x plus 1 raised to the power of 4 d over dx times 2x plus 1 again, and then simplify again. So 4x 4 multiplied by 2x plus 1 raised to the power of 5 multiply by x cubed minus x plus 1 raised to the power of 3 multiply by 3x cubed minus 1 plus 5 times x cubed minus x plus 1 raised to the power of 4 times 2x plus 1 raised to the power of 4 times 2 is equals to 2 times 2x plus 1 raised to the power of 4 times x cubed minus x plus 1 raised to the power of 3 and multiply 2 times 2x plus 1 times 3x squared minus 1 plus 5 times x cubed minus x plus 1 and simplify again. So it's equals to 2 times 2x plus 1 raised to the power of 4 times x cubed minus x plus 1 raised to the power of 3 multiply by 4x plus 2 times 3x squared minus 1 plus 5x cubed minus 5x plus 1. Then simplify 2x squared 2 times 2x plus 1 raised to the power of 4 times x cubed minus x plus 1 raised to the power of 3 multiply by 12x cubed minus 4x plus 6x squared minus 2 plus 5x squared minus 5x plus 5. So the final answer is 2 2 times 2x plus 1 raised to the power of 4 times x cubed minus x plus 1 raised to the power of 3 times 17x cubed plus 6x squared minus 9x plus 3. So that's all. Thank you.